we continue the discussion on bending or beam bending in this video, and I intend to discuss bending moment diagram. We did discuss the shear force diagram in a previous video. I'm going to use the same problem to discuss bending moment diagram. So basically what we have is a beam supported at either ends and acted upon by a point load. Let's call this 10 and call A, B and 2 meter each. We did discuss a similar problem to calculate and draw the shear force diagram, which I just show you here. So we had calculated the reactions for the applied load of 10 kilonewton, the reactions at A and B. In this video here, if you want to recollect, please go and view this video here. We did calculate the reactions at A and B using the equilibrium conditions. Total reaction would be equivalent to the applied force, and you take moment about the point A or B, and we have calculated the reaction at A and B is as a 5 kilonewton. So we now know that RA and RB is equal to 5 kilonewton, and I'm going to use the same problem to calculate the bending moment diagram for this force system. If you want to know the details of the shear force diagram for this case, please go and watch this video here. Now moving on to the bending moment diagram, as I just mentioned, we now know the reactions at A and B are 5 kilonewton, which we have calculated in the shear force analysis. Now, as in the shear force case, we use the sections method or method of sections in calculating the bending moment as well. So you take a section between each force points. So you have a force point here, another here, and another at point A. So you first take you can calculate from either end. You can either calculate from A or B, but make sure you once you decided the point where you calculate the bending moment from, then make sure you keep the same point for every analysis of that problem. Now let's start from the point B. So you have to assume a section at a distance x from point B. So you have a section here x, a section x, and say this distance x, and you have the load RB here. Now take the moment of this particular system, only this system. Don't worry about the entire force system, just take the moment of this system. So take the moment about the point or the section. So you have a force acting at x distance from the section. So the moment about the section x is equal to RB times the distance, the force times the distance, that is x. Now you need to allocate values for this x. So at x is 0, moment will be RB times 0, that is 0. Now the maximum distance that x can have between these two force points is 2 meter. So at one condition, that is at B, x will be 0, and at this point x will be 2 meter. So the maximum condition at x equal to 2, moment is RB times 2, that is 5 times 2, that is 10 kilonewton. Hope you understood this. Once again, always make sure once you decided that you're taking moment about you're starting from point B, point B here, make sure you keep the B as your starting point all the time. Now moving on to the next next section where you have force points, or next section between two force points. You can draw another line here. You have RB, force of 10 kilonewton acting at 2 meter from RB, and your next section X here. Now moment about X is, as you can see, there are two forces. When you look from this point, always look from this point. So you have a 10 kilonewton acting downward and an RB acting upward. So the force at the maximum distance is RB. Now that is, the moment will be, because it's a counterclockwise moment which is rotating in this direction, we take this as a positive moment. So that is RB times the distance, total distance from this point is X plus 2. So that's RB times X plus 2 minus 10X, because this is creating a clockwise moment about the point here. So that's a clockwise moment, this is an anti-clockwise moment. Applying the same analogy as before, at X is 0, moment is RB times 0 plus 2 minus 10 times 0, that is 5 times 2 minus 0, that is 10. And once again, the maximum distance that X can have between these two force points is 2. Now your section is here, so the maximum distance is 2. So you apply the extreme points, one is X0 and another is X2. So at X equal to 2, moment is RB times 2 plus 2 minus 10 times 2, that is 5 times 4 minus 20, that is 0. So you have 3 moment values calculated, 4 moment values, sorry, well, in fact 3. You have 1 here, 2 here, and 3 and 4. So that's your 3 and 4. In fact, your third point and fourth point are the same value of bending moment. It's not 10 kilonewton, it's 10 kilonewton meter, because you have a force and a distance. Now you can draw the bending moment diagram for the system. So you have your force system like this, and like this the load, and this you've calculated the moments for all the cases. So in order to draw the diagram, just extend these lines, and you have the 0 line, and at point B your moment is 0. Here also your moment is 0, and at the point of application of the load, the moment is 10 kilonewton. So you have your moment value of 10 kilonewton here, and because that moment equation is a linear equation, you can see this is the equation for moment is RB times X. So the variable here is not a square value or anything, it's just there is no square value for, so you can see that is a linear relation, so it will be a straight line for the moment diagram. So you just joined the points of maximum moment and minimum moment, and same on the other side. So that will be your bending moment diagram for the force system. We will continue with the similar topics in next videos. Thank you for watching.